And we're back with Online with an Architect. My name's Josh Odgers. We've got another great episode for you, welcoming a very special guest from Singapore, Iwan Rahabok. I've screwed it up. Sorry, mate. I'm going to have to edit
It's
this
okay,
out.
man. You're not the first one. You're not going to be the last one.
I'm so sorry. All right. Very casual start to this one. All right.
Yeah.
So, do you want to give us a quick intro of yourself for those who may not know you? I'm sure most people in the virtualization space have heard of you and seen a lot of your content, but let's give a quick intro about yourself.
Yeah, thank you very much. I joined VMware about more than 1.5 decades ago, right, from Sun Microsystem. And so I was a Solaris guy. So looking at x86, it was like a toy, I wasn't serious about it. Oh, what is this, man? What was vMotion? How did you do that? I didn't believe it basically. But because my sales was applying for VMware and he asked me to come along. So yeah, I come along and I started as an SE for the global accounts. So at that time back then, Citibanks, JPMC, etc. They were my first customers. And then about 8 years ago, I got a call from Chandra from Palo Alto, and he said, why don't you come over to Palo Alto and help us with the products, because we've seen your book, we've seen your blogs, we think we could help you. So I spent 2 weeks there, and that basically changed my life from a local guy in Singapore to serving customers, and then became part of the product team. So Mike Sumner, you probably know him. You know Mike Sumner, right?
Yes, I do.
So Mike Sumner helped me transfer out of Singapore to global. So ever since then, pretty much I've focused on the operation side, looking at the metrics, looking at the alerts, right? And I work closely with the vSphere team, vSAN engineering team, and that is now I'm part of the VCF divisions team, right? That's basically about me. Oh, the book on the metrics, right? It started about 10 years ago. You probably know John Arashid, right?
Of course,
Who doesn't know
good friend
him?
of mine.
Who doesn't know him?
VCDX #1 for those who are listening.
Exactly, right. So John was telling me back a long time ago is that he had written multiple books at that time and said, Iwan, you should write a book. I said, John, man, no way I can write a book. It's just too much effort. Right. So started with, I was aiming for a small book. So 10 years ago, I published the first book. And so every a few years, I would update it. Right. And the first 2 editions, it was with a publisher, but then I found out that there's so many copies of the PDF lying around on the internet. So I said I might as well just give it away. So at the 3rd edition I made it free, and I made it available in Microsoft Word so that people don't have to deal with PDF anymore. You can just take with Microsoft Word. So the 3rd edition and the 4th edition. And then this book, which is the 4th edition, which is coming actually in January or February, someone in Australia actually is going to write a forward for this. It became too big, George. It became like 1,000-page. I've been cutting content, so eventually I took out the vSphere metrics content and made it into a separate book. And that was also the other reason for that is the ESX Top Bible, right? I was complaining internally, to Duncan Epping also. Yeah, look, this hasn't been updated for 10 years, and someone's going to do it. And nobody did it, so I guess I did it. So that is how it got. It became 1st edition, and then John did a review on the 2nd edition, and then you will see the 3rd one coming in January.
Yeah, fantastic. I think you've hit the nail on the head. It takes someone to take on the responsibility. It's not just like someone like Duncan or whatever. He can't do everything. So people in the broader organization have to take things on, and a credit to you for taking on that task because it's not an insignificant one.
No, it is actually quite an amazing, I think, message just sharing with your audience. If you asked me 10 years ago that I would have done it, and I said, no way, I think you're crazy. But here we are talking. It's going to be another long journey, but we've come a long way.
Absolutely. Well done for all that effort. And I think everyone who's read your books and your content over the years really appreciates it. So, thank you on behalf of everyone.
Yeah. Well, most welcome. I learned a lot from the community, so I think this is a good way to give back.
Yeah, absolutely. Community around VMware, virtualization, everything has been fantastic for me as well. So I can echo those sentiments for sure. So today, for those listening, we're going to cover some really cool stuff. So if you're a vSphere admin or you're an architect or an engineer and you're trying to either learn about vSphere and virtualization, you're an application person, you're trying to learn about performance and the various metrics, you're trying to optimize your environment or get a better bang for your buck out of your environment, we're going to have a lot of tips for you today, or Iwan's going to have a lot of tips for you, and I'm just going to be here enjoying the show. So looking forward to this one for sure. So let's kick off. Tell us a bit about the metrics in general and why they're not really what people necessarily think that they are.
Okay, so I think then let me share the other one, because I was sharing the screen window. This guy. Okay. Yeah, the metrics, right? And so there are many nuances. You can see the screen clearly, right? So
perfect. Yes.
There are many nuances. And the reason, Josh, is because we in an IT industry, and not just VMware, if it goes back, like, VMware has its roots back in Linux, in Unix, right? Which in turn, Unix has its back in, I guess, mainframe, right? And so if you look at metrics in general, whether it's Windows, whether it is NSX, or it's vCen, or Red Hat, or Linux, right? There's a lot of legacy around it. And so as a result, we as an industry, we never agree on this on the terminology. Like you may call it usage, I may call it utilization, somebody may call it run, right? And after a while, what does it all mean? So it gets confusing. So there is the naming's complexity, right? And with all this thing, and you could have the same name with a different purpose, right? Or different name with the same purpose, right? Or the name itself is confusing. And then you have an architecture complexity, right? And the nature of CPU, which now you will have a GPU, you will the nature of all these things. You have a tiered memory now. All these things are fundamentally different. And in terms of metrics, concepts such as utilization, reservation, allocation does not equally apply. And so all these things and other nuances, right? The way you roll up, even unit, we talk about giga, GB, right? And certainly there's a lot of choice. There are 7 choice for ESXi CPU consumption. So the question is, which one do you use, right? So all these things, plus of course virtualization, right? When we virtualize, things becoming more complex. Now there is another layer in between Windows and Linux and the underlying hardware. There's this thing called the hypervisors, right? And that is why Kubernetes is very complex, because it adds yet another layers. So all these things got me down to basically document all these things and see what in the community, right? How do we then collectively review this thing and improve this thing so that we as an IT architect, we're not bogged down with internal kitchen matters, because all these things are irrelevant to a CIO, is irrelevant to a CEO, right? This is kitchen stuff, right? So let's get the kitchen stuff out of the way. This documentation, I hope your audience, right, would then, let's collaborate. This is far from complete, by the way. I know it's 375 pages, but it's far from complete, right? So all these things is why they are complex.
Yeah, absolutely. And I think in my career, certainly, in the past 15 years or however long I've been doing virtualization, a lot of the metrics are misunderstood. And even the ones that are understood are sometimes used out of context as well. So yes. I think context is important to a discussion. And I think the obvious example was I wrote a blog many years ago, and I still refer to it actually, in recent times. It was titled, I'll put a link up, it's called High CPU Ready with Low CPU Utilization. And basically, as you well know, but for the listeners, in this scenario, if you just look at CPU utilization and it's 20%, of your ESX host or your whole cluster. You might go, oh, I've got heaps of CPU capacity. I can run a lot more applications, or I can assign more resources and things like that. But if we then look at CPU ready, we realize that we're actually constrained at the scheduler layer. So actually, our CPUs are overutilized, not underutilized. And then on the opposite end of the scale, you could have really high CPU utilization at, say, or not really high, but you could have, say, 80% with very low CPU ready. And I would argue that's a fantastic result. 80% utilization is fantastic. You've got low contention, CPU ready, and that's probably almost the nirvana. That's pretty much a target state. But then people set alerts at 80% CPU as if it's a problem. When if there's no contention and your CPUs are being utilized, this is fantastic. This is a great day. So I always refer to that one, and there's a graph, showing when you right size that you drop the CPU ready, the utilization actually goes up, and therefore applications can perform better.
Yeah. Allow me to. You can see this state diagram, right? And I can't recall where I got this state diagram. I know Valentin Bonzio had one of this, but I'm not sure who is the original person who drew this thing, right? Like you talk about CPU ready and CPU utilization, which at the core, at the most fundamental, utilization is a higher level matrix that is derived from run. So CPU run is the most basic one, right? And CPU ready, my take on it, and happy to be corrected, CPU ready has to be seen as a function of the CPU run. As in, if you have 5%, if you have a 2% CPU ready, but your CPU run is only 8%, so that means 2 out of 10 or 2 out of 8. So that is not good. The application only needs about 10%, but because it wasn't doing much. But that 10%, 2% is actually in ready. So that 2% ready is actually not good. Now, if your run was 98%, the 2%, the application may not feel it because it's doing a lot of it gets a lot of things done. In that 98%, it gets a lot of things done. It processes, I/O. It does computation. So the 2%, the application may not feel it. But if it's only doing 8%, it may feel it. So that is one part of it. The second part is you mentioned earlier the CPU run, right? I was looking at the various methods of documenting metrics. Like Brendan has this wonderful the use method, right? And then the team at Weaveworks have the red method, and then Google has the golden signals, right? So when I looked at it, and I asked myself, how do I explain these things to VMware's admin, right? And so I came up with this triple C method, which basically say, related to what you said earlier, check the contention first. If your contention is low and your CPU run or utilization, let me be clear, your CPU run is 100%, but if contention is 0, this is like your checkout counters in supermarket is all filled up, but there's no one's in the queue. So why do you worry about it? There's no one's in the queue. So look at the contention, look at the consumption, and then look at the context surrounding it. Is this normal? Is this what we expect from a business standpoint? Right? So I think, and then so the entire book is following that technique was contention, consumption, contention, consumption. And I hope that I'm sure you know Mark Artimagic, right?
Yes, I do. Yeah, very long-standing VCDX, very smart man, and is the king of performance, I would say, for VMware, or one of the kings. There's quite a few.
So interestingly, I think in 2017, and I cited him in my book. So in 2017, he and I kind of like independently come up with basically we say drive-by. We basically say drive-bys. He said drive-by contention. I think that is the word that he used, right? And that is what I've been telling my customers, that the perfect performance is when utilization is at 100%, but there's no queue.
Mm.
There's no queue inside, and there's no queue outside. There's no ready. There is no CPU run queue. So your CPU is perfectly fine. Or let's say your memory, your free is 0. Your free memory is 0, but you're not swapping. You're not having to pitch out. You're not. So why you worry? There's
This
nothing
is
to
actually
worry.
the goal of virtualization, is to optimize the utilization of hardware, which was very low in the physical era. And in the virtualization era, we really do want that 80 to 100 mark. And I think it's that feeling that we have from the legacy physical environments where we look at high CPU utilization as a problem, whereas it's actually great. In virtualization, high utilization with no contention, like you say, is pretty much where we want to be. So, yeah, I couldn't agree more.
Yeah, you see this thing. This was an escalation. I'm sure you know Valentin Bonzio also.
Yes.
Yeah. So this got escalated to us from a banking customer in Europe. That was pretty near Christmas, and it took me 13 pages to answer to convince customers, and eventually he granted me the permissions to take the screenshot after I hide the company name. So he was looking at vCenter, right? And in his environment, and they said, "Hey, what's going on here? This is my ESX, and how come the first counter is about 45%, which is my utilization? You look at the average is 35% here, right? The max is 55%. So he said that utilization max at 55%. My core utilization, the green one, it's at 85%. It's over here, by the way, right? And my usage is at 100. So he was asking, so which one is which then? So what is my ESXi utilization? And unfortunately, George, old habits die hard. If you look at the various screens in vCenter, and I guess also in Windows, in Linux, you see this line. This is what you see.
Yeah.
In reality, there are 2 more lines. Now, my 2 cents, and I'm happy to have a discussions on this thing. My 2 cents is the answer is somewhere in between these 2 numbers, closer to this number. And I explained the way the accounting of each of these metrics, right? And so net, if the answer is somewhere in between, that means you have room. You have room. So now it goes back to what you say. How comfortable are you in pushing the utilizations higher? How comfortable are you? And it's a little tricky because contentions can happen at the point of a commit, right? Because you have a risk that you could have a contention because you are off a commit, right? So that is why if you ask me my answer to customers is look at this number, these 2 numbers. Don't look at, this number is what you see. This is what you are comfortable. Been seeing it since high school. I get it. Okay. But look at these numbers also, and look at the contention numbers. That's how you know how much room you have.
Yeah, I like what you said earlier that you and Mark had discussed this, and you agree that you've got to look at contention first. And that's something I've always done as well, because if there's no contention, then whatever the number is great, pretty much. Like as a general rule, as a starting point. If we're not contended, then that's great. So I always, look at ready. I look at contention. I look at weight. I want to know if the storage is a constraint. And if neither of those are a constraint, then the utilization, whatever number that is, it could be high, it could be low. It doesn't really mean anything. So that's been my rule of thumb for a long time. And, even with HCI, of course, we've got like vSAN. It's still using CPU under the covers. So we want to make sure there's no contention for the virtual machines. And we want to make sure that vSAN has resources on the host as well.
That's right.
And that rule of thumb works really well, even for HCI environments where CPU is possibly more critical than it is for traditional shared storage.
Yes. So in that environment, especially if you add network virtualization such as NSX, because it is also a kernel module, right? Yes. So your kernel becomes bigger. your overhead, so to speak, become bigger, because not just compute, but there's compute, there's storage, now there's network. It's 3 in 1, right? This gets tricky in the way you do, for example, capacity, right? What do you allocate to the kernel now, right? Do you allocate based on the reservations of the kernel modules, or do you allocate based on an actual utilization of the kernel modules? And it's a little tricky. And my 2 cents is maybe to be safe, I'm thinking whether you take the highest of the usage, actual usage. Let's say vCent. So the vCent, the kernel module, the daemon is it's running like this, but it may be reserving like this. So right, and so one possibility is you take the highest of the 2 and say that is my baseline, that is my so-called overhead, and then the rest is for the workload, right? And or you simply take the reservation. It's tricky on that thing. You mentioned just now on the ready. I would suggest that customers looked at a couple of things. You looked at ready. I think you want to look at overlap. You want to look at overlap and plus, so overlap plus ready plus co-stop plus this is a mistake. This is called other weight. So I would sum up these 4 counters, and I would say and I would track it as an absolute, because the guest OS, the workload doesn't know and doesn't care whether it is stopped because of overlap or because of co-stop or because of other weight. It just knows that it's being freeze. But I can't run because I'm not being scheduled for whatever reason. I'm not being scheduled, right? So that's what I would say, that at these 4 numbers, and
Yeah, absolutely. I think you're spot on. I think the application doesn't know, which is why it's not a lot of point monitoring within a virtual machine either, because your stats are very skewed based on when it is scheduled and when it's not. So to me, one of the biggest mistakes of virtualization I see, apart from storage, obviously storage, there's a lot of mistakes people make, but from a CPU and RAM perspective, was attempting to overcommit memory. I think traditionally has been a disaster. People think it's a magic solution and it just works, and it's not really that great. So I personally don't like overcommitting memory at all, and I've never really liked the idea. But CPU, people think that because CPU overcommit works, in my opinion, very well, that it's also magic, that you can just overcommit to extremely high levels and expect to get a good outcome. But that's not really the case. So, I think the rule of thumb, and I'm not sure where this rule of thumb came from, but I've certainly found it to be true, is at about 2 to 1, even for reasonably critical applications, and I'm not necessarily talking about, the most critical application, but I would say for 95% of applications, if you're overcommitting 2 to 1, you're very safe. And some applications you can overcommit, 3 or 4 or even more to 1. And those are generally pretty safe. So it's sort of like 2 for business critical apps, 3 for mixed workloads, and then 4 for just general workloads. And then VDI is obviously a lot more. But those seem to have fallen or proven to be true over many years, even on HCI environments where there's a bit more CPU dependency. But of course, CPU ready can occur even with very low overcommitment as well. So this is another thing. People think that, we're only at 4 to 1 or we're only at 3 to 1. We're not going to get CPU ready. Well, that's not true. You can get CPU ready at 1.1 to 1, right?
Yes,
and
correct.
So, you do, in fact. You do get CPU ready at 1.1 to 1. It's just not significant in most cases. So it's about measuring the significant contention in something like ready.
Yeah. So 2 things allow me to add here. Again, this is that's why I'm very happy with this. As I jump in right away when you offer this thing, is let's have a broader dialogue. Because when we looked at memory at the ESXi layers, right? And I think if we do it, this one, I think it's here. Okay. So basically what we're saying, if I follow the theory of the memory management, a lot of these things are cache. And so if I just if you Google Linux ate my RAM, so Linux does a lot of caching, Windows does a lot of caching, ESXi at the consume level does a lot of caching. So you got two level of caching. So as a result, you notice that your ESXi consume memory tends to be very high over time. And then when the VM isn't doing much, you leave the VMs idle. Let's say the VM is 16 gig, right? And after it's consuming the memory with 16, you shut down the application. So it's just Windows running. And you notice that an ESXi layers, the consume would remain 16 gig for days. Because ESXi doesn't know when are you going to need it again. Since I'm not under memory pressure, I'm not going to trigger ballooning. I'm not going to swap those physical DIMM because it takes effort to cycle all this 1 terabyte of pages and knowing who doesn't need it anymore. Right? So ESXi just keep it there. So the one that I'm interested talking to your audience is, because of this two level of caching, it's does it mean now we can say, okay, guys, can we look at an architecture principle where, let's say, the test and dev environment, we do a memory over commit because of this caching concept. Now, again, of course, you are driven by contention, right? You track the contention counters. Inside Windows, I guess you may have to track the page out counters, page in counters, right? And we can track this thing at scale. Actually, we can actually model it and then develop a so-called guidelines and on this. And because if you can save, then it's good, and you save money basically. Yeah.
And yeah, you're saving money in the physical realm with hardware, obviously with RAM purchasing for those listening. So, obviously RAM at certain times, I don't know about right now, but RAM has certainly been, one of those pain points, especially when you get high amounts of RAM in each host. That can drive costs significantly. So I don't track pricing as much as maybe I should throughout my career, but certainly, when we look at bill of materials, sometimes RAM can be a significant factor. What I find more so than RAM is all the other components in the solution are a factor. So it's not one that I find a huge constraint these days, at least. But certainly, to your point, if VMware as a company can track a lot of this data and model it at scale, and for certain workloads or maybe service providers, for example, maybe the hyperscalers can track it, it would be very interesting to see what could be achieved theoretically for customers, because then obviously architects like us can give really good guidance based on a quality data set.
Yeah, because one of the things that I'm thinking, that out of the box, I'm going to give you another counter. In ESXi, I would give you the sum of all the guest OS memory use plus your VM kernel. And then I will compare this thing with your consume. Because if the sum of all the guest OS, the sum of all Windows or Linux in that box, let's say the sum is 500 gig, your consume is 1 terabyte. And assume your kernel, let's say, is 50 gig. So the question is, what is this 450 gig left that is not inside the guest OS? Right? So they are mapped. They are just passive pages. So one way is I give you that counters. Then, as you say, as an architect, you can look at these data points. Okay? The sum of guest OS in the box is lower. And I've seen those numbers. The challenge, George, is sometimes I see a higher number because of transparent page sharing, right? So this is where the tricky part. I'm thinking at this moment, I just give it to you, and then you have to make the call, on workload by workload. Yeah.
Yeah, I think that's why customers need good architects as well, because even if let's say you and I did this study together, we did it over 5 years, and we got just hundreds of thousands of customers worth of data. There are going to be customers that fall outside that guidance, and this is where best practice guides get abused is people assume they will always work. And that's why it's always important for an architect to review a specific customer's environment and requirements, and make recommendations specific to that. Just like a doctor has to give different advice to different people because we're all unique. So architects are the same as that. So I think it would be good to have some guidance, but certainly I don't think there can be a rule of thumb with memory in the same way there can be with CPU, because it's much harder to resolve a memory contention issue. Because CPU, obviously flips in and out and turns on and off all the time. Memory is far less flexible.
Yeah, it's a form of storage, actually. It's sticky. It's like a disk space, basically.
Yeah, absolutely. So one of the things you and I discussed about this episode off air was you have a theory that customers can potentially get around 30% better result or lower total cost of ownership by focusing on metrics. And I think you're right, just at a high level. My gut feeling is that's probably true, because I've certainly seen environments where I feel I could optimize them, quite easily to 20, 30, 40, 50%, just by making some simple changes. So very curious to hear your theory, and let's dive in deep.
Yeah, just look at this one, like this particular customers, right? So if he was to simply look at the screen display in vCenter and in Windows or in Linux, etc., he would look at usage. It's 100% flat out. So, and because the good news is that this customer didn't believe it. I said, how come it's 100%? I was just running because he was running some workload. He was doing some test workload, right? So he knew that this is not correct. And if you notice this usage is flat, even though there was a spike here, you see this thing spike like this, and this thing remains flat.
Yes.
So you could tell that this particular counter, just with, I documented the formula behind it, but just by observing the outcome of the formula, you could tell this guy went up to 100% very fast compared to these two. It is more sensitive. It went up 100%, but after that, it is being kept. It can't go further. It is mathematically being kept because this thing went up, this thing didn't, right? And so what happened here in the reason for this, okay, so there are two reasons here. The first reason, the usage counter if one of the thread in the core is used, it goes to 100. It's one of the threads. So I think it's easier. We go down here, this part. So if one of the thread, this is hyperthreading, the first one, this is the second one. So we are inside a single core here. So the moment the core runs at 100%, usage goes up to 100. So that's one part. The second part of usage that goes up to 100 is Turbo Boost, which is, if I show it to you, it's gotta be, let me see, this guy. So this is your clock speed. This is your nominal. You bought the box. It's saying 2.4 gigahertz. But Turbo Boost at a single core, and the counter is done on a core by core basis. So when you see a socket, it's an average, and so you could have, in a 20 core, you could have one core very busy, the next core is idle, and that particular core is consuming a higher power than the next core, right? So long the power envelope within the socket is maintained, is fine, right? Because you're not consuming more, because you bring down the other one, right? So you could be running at 3.9. So at this moment, you are running more than 50% faster. Usage will go up by more than 50% by this. If you run at 3.6, your usage will go up by 50%. So the question becomes, see, at 2.4, you are already running at 100%. because that's what you bought. But your box is capable of turbo boost. It's capable at that particular second. So if you are, in a sense, just relying on usage and not looking at other counters, so you could be leaving money on the table. And where was it just now? Yeah, so that is on the CPU side.
And just to be clear here, I guess, to everyone, we're talking about making more efficient use of what you have at this point, right? We're talking about monitoring your current environment. We're not talking about resizing or re-architecting or buying new hardware and getting a 30% benefit. We're saying, look at what you've got today, look at these metrics, and there's money on the table.
Yes, just by looking at the accounting. Because there are 3 counters here. It's not one counters. Right now, I would say why the world, looked at usage, because, it goes back to like 20 years ago in ESX 1.0. Right? At that time, hardware is very different. And at that time, things were, you had to be really conservative about things. So usage was appropriate at that time. But now you have like 20 core, 40 cores a socket, right? So that is on CPU. So I'm interested to know, what do customers see, and you plot this thing against your contention, right? Let's say this is ESXi. Let's say this ESXi, let's say, have 50 VMs. Okay. So what you can do is you can then plot this against the highest CPU ready plus co-stop plus overlap plus other weight of any VM in the box. If that number is low, why you worry? Like what you said, right? You drive by contention.
Absolutely. I think this is such a critical topic, and one, obviously, why I reached out to you is I thought this would be a very interesting topic. And certainly, with all the new licensing models, people are trying to make the most efficient use of their licensing and save money where they can. This is a great topic, right? VMware by Broadcom has hundreds of thousands of customers who can benefit from some of these simple concepts. But they're simple because you're making them simple, right? You're presenting them in such a great way. But these are not really that simple concepts. You've put in 10 years of work to get to this point, to share this experience with people. So, yeah, I think there's a lot of advantage here for customers to get.
I see it that it is not simple. It took me 13 pages and multiple rounds to convince the customer, right? So we eventually documented this thing, have the proof ready, to show that the explanation makes sense, right? But as what you say, right, different customers have a different situation. You need an architect that would guide the customers. Look, I think we can start with this environment. This is safe. Let's plot the sum of the highest of all your VMs, CPUs. I put the contention counters. Let's say I put it here, right? So you sum up these 4 counters, and if it is low, right, and then you can work from there. And I think you can save. I'm keen to collaborate with your audience and save on that. So that is on CPU.
Yeah, actually, staying on CPU for a moment, there's a couple of things I want to mention here. So I've had many customers over the years where, especially database administrators, right, they're used to the physical servers, they like the dedicated hardware, and they always ask for a lot of CPU. And vSphere admins are screaming at the screen right now because everyone's had this request to get 16 or 32 vCPUs or something crazy.
Yes.
I remember a customer, it's quite a long time ago, but it was a very critical environment for a very important organization. And they were having database performance problems. They were virtualized. And, I was called in as the escalation to have a look at it. And I had a quick look, and 5 minutes later, I was like, okay, cool. There's a heap of CPU ready here, just a ton of it. My analysis was the hosts were undersized. They were overutilized. VMs were, oversized. There was a whole bunch of what I would call common 101 level mistakes. And I said to them, look, we need to do a right sizing exercise. But for right now, you're in basically a critical situation where your application is almost down because its performance is so bad. It's intermittently working. We need to shut down this server and reduce its CPUs. I think it was from 8 to 4, right? This is a long time ago. And they said, there's no way. It's running at 100%. And I said, yes, it is running at 100%, but it's also got 50% CPU ready. So it's not actually using half those cores anyway. So if we, by simple math, we go, okay, it's only using 50% of the cores because it's ready half the time, then we drop it to 4. Even if it runs at 100%, at least it's going to get most of those cores most of the time. So we did that. And not surprisingly, CPU utilization was just pegged at 100% in the guest, as per your example. But the application started performing really responsively. In fact, they were very happy. They said, oh, wow, this is amazing, but we have to put it back to 8. You can't leave it at 4. It has to be 8. I said, well, look, if you put it back to 8, you're going to pretty much cause yourself an outage. But that's just a great example of, a lot of the time less is more when it comes to CPU. And if we resolve that contention, we can improve performance, massively. I just remember that specific example. I wrote a blog on that one as well, because there's a lot of pushback even today about right sizing. And right sizing has been a topic VMware have championed, I think, very well for at least 10 years, probably more. But still, people oversize their VMs and they don't right size. And this leads to increased cost and lower performance.
Somebody sent me this Excel long time ago. And so he got a list of thousands of VMs. So the Excel is pretty big. So it was generated in area ops view, because you have a list of VMs, and then you say the CPU 0 utilization, and then CPU 1, CPU 3, right? And then all the way until CPU 63, right? And of course, there are, some VMs are smaller, some VMs are bigger. So it's a VM that is only, for example, 8 CPU, the CPU, it will only show 8 columns, right? It only fill up 8. And so he's got this long Excel, very wide, right? The 64 columns, and then going down thousands of VMs. And he simply plot the CPU, individual vCPU's utilization. And what is interesting is you could see that the VMs, the bigger one, gravitates towards the first few CPU. It's not even. So you give it a big one, it's not using it anyway. There is an imbalance in the utilization.
Yeah, absolutely. I remember seeing this really funny animation. It was like of a person dancing, going crazy, and it had labeled CPU 0. And then it had all these people standing around watching. And I just remember that. And I'm thinking that's exactly what we see in virtual machines. It's CPU 0 is really busy and none of the other cores are doing anything.
I have it somewhere. There was an imbalance that I posted in and I created the CPU usage disparities metrics in area ops because I saw an imbalance inside the guest, basically, right? I had a chart somewhere.
I think credit to you that you've made this available in Word as well to everyone. This is really great content, which I'm certainly going to try and make the time to read through as well. Because there's always things to learn, and I think
my hoping is like say you're an architect. Let's say as a customer, right? So you architect, let's say, an environment with 10,000 VMs. Okay, so you're the architect. You look at the storage design, CPU, server design, etc., right? And you account for availability, for performance, etc. But you're not the one running the day-to-day operation. So you got to hand over something, right? Like a guidebook, so to speak, right? So that is why I gave it in Microsoft Word. Is then what you do is just you take whatever relevant, right, and then you just create your own document.
Yeah, and I think this is one thing that's very important, that obviously the VCDX methodology and process teaches all of us who've gone through that is, it's very important to consider the day 2 operations. So yes, we design things, we might implement, most architects, certainly VCDXs have proven their ability to implement as well. I think that's one of the values of that program is you get the architect who can also deliver the outcome. But also, I think less VCDXs have had that day two experience as being a sysadmin. I mean, a lot have, but I think, a guy like Chris Muchler, he's been on the show. He talks very much about the importance of thinking about operations. And one of the things that we produce as VCDXs for our application is installation guide, operations guide. I call it operational verification as well, troubleshooting guides, all this kind of stuff. And some of the metrics we're talking about today, especially the contention piece, I think should be part of every design. And every vSphere admin should get a handover from their architect showing them the key, let's say the top 10 things to really look out for. Because really, I think if we nail the top 10, like, yes, number 11 is important, number 12 is important, but the top 10, if we get those right, we've probably got 80 or 90% of the benefit already in just doing those top 10 things correctly. And that's something that's realistic for a sysadmin to do. If we give them a list of 100 things, that's completely unreasonable. So I think out of this podcast, if we can get 10 things to monitor, that would be a great outcome for everyone.
Yeah. This is actually pretty, okay, there are two parts here. Since you mentioned VCDX, right, I was discussing with John, right, and I said, John, it seems to me, from a concept standpoint, John, there is an architecture, there is an operation. And just because you can build a space shuttle doesn't mean you can operate it. You need to be an astronaut to operate a space shuttle, right? And so as an architect, so there is, I'm not saying the VCDX cannot operate. I'm saying that there are two parts of the skills, right? You need to design it, and then you need to be able to operate it. There are two skills. The skills can be in one person, right? And it can be one certification.
There's there's design, and there we talk about enterprise architecture and solution architecture as two sub elements of that. There's the implementation piece, so the VCIX, implementation expert sort of level, and then like you say, there's operations. So there's definitely three parts, and I think any customer who can find resources who can cover all three, just grab hold of them, right? Because you want these people. And Chris Muchler is a great example of one of those people because he's had a lot of experience in large organizations doing those day two operations, and as a result, a lot of the recommendations he makes in some of his YouTube videos, it shows his experience, and it shows that he really considers the day two and the sysadmin, and that's certainly something I try and do as well. Because if I design something and I hand it to you, and it's a nightmare to look after, and it's terrible performance, and it's not resilient, and it's horrible to maintain, then I've really done a bad job. So I always think of myself as the sysadmin, and if I don't look after the environment I'm designing, then I need to fix that before I hand that over.
Yes. I 100% agree on that. That's why I had in my mind, like I wrote it in the book, that the real architect, how you know who's the real architect is when you have a major outage, the owner of the hands on the keyboard, that is your real architect, because that is the one that is saving you, right? And so it's very production oriented, right? And back to your point on the top 10, it is something that has always been, in a sense, we had some, we made some attempts in VMware, now Broadcom here, right, on what are the things to check, right? Because at the end of the day, the metrics are just theoretical. I'm interested to know CPU ready, but what does it mean? I need to know what to do, right? I'm just an operator, right? I don't need to know the details, man. I need to drive this F1 car, not to build it. You build the F1 car, I need to drive it. Okay, you just tell me I'm a good driver. How do I drive this car, right? And so it is something. So my other book, which is this ops transformation, right? We try to basically get into this thing, like defining an SLA, right? Defining what is performance management. I'm trying, and with a prescriptive dashboard at the end, that this is what you do every day, this is what you do every week, this is what you do every month, and then we define who are you, because there are different persona.
Yes.
Right. There are those who are focused on the day. I don't really care about yesterday. And then there are those who care about, I care about 1 month ahead, right? Because let's say I'm a capacity guy, right? And so this is something that is in my mind. This second book, George, I'll update it for February. I'm happy to give you the draft and review it. That is the consumption, in a sense, of all these metrics. How do I hand over? I wish one of the goal behind the book of this ops transformation and is I want to give it to a customer so that the customers can say, look, I have architected, guys. Don't worry about it. According to the best practice, by the way, this is how you operate it. And it has to have their name on it, not my name. That is why it's in Microsoft Word. Right? This is how you operate my architecture. I have designed it, guys. This is how you operate it. This is who does what. Because I'm not doing that, guys. I'm the troubleshooting guy.
Yeah.
You call me when there is a problem.
Such a critical part of architecture is defining who are the people responsible day two. And even stakeholders throughout a design phase. It's so important to identify them and make sure it's documented what they say and what their role is and who's responsible. And then map that through all the way through to day two, not just the installation. Let's say I do the design and installation. That's fine. I'm the stakeholder and responsible party for some of the steps. But who do I hand it to? And when I hand it to them, it's not just here's a document, see you later. It's here's a document. Let's go through it. Let's do a handover. Let's make sure you understand it. Because as far as I'm concerned, a quality architecture documentation set, which includes operational procedures and things like that, must be able to stand on its own. It shouldn't be dependent on me coming in and talking to the person every day, right? Obviously, we do a handover to make it easy, but the document should be self-explanatory.
Okay. Sorry to interrupt, Josh, because this gets me into a very exciting things, right? You hand over to somebody, okay? And the guy says, what is VM kernel? Oh gosh, now I have to explain VM kernel to you. And then you say, okay, there is this thing called CPU ready. What is CPU ready? Oh my God. If this is the case, then it's going to be a challenge for me to hand over this to you because this is an F1 car. This is not some, this is an F1 car I've designed for you. If you're not an F1 driver, it is not going to go anywhere.
I know where you're going here, and I completely agree.
So John and I, a bunch of us in Christopher Kusek, right, and Brock Peterson, right, we talk about, I think maybe there needs to be a basic VCP level, like VCP operations management, a kind of basic certification so that I do know that you understand the basic operations. So I, as an architect, don't have to go to such a low level. I mean, I can't document everything, right? And it is, even in my book, that 375 pages, I assume you know CPU ready as a concept. Because I'm not going to explain it. Because there will be thousands of pages, right?
Yeah, I think every document that's produced or a book or anything like that, or a presentation even, there has to be some level of assumption of a minimum level of skill. So even this podcast, right? People need to know what VMware is as a company, roughly what the products are, and roughly what they do. Otherwise, they're not going to understand anything we're talking about. So that's kind of the assumption of this podcast, and that's the assumption of most documents that are produced. And in my history, I usually write what that assumption is, that this document intended audience is someone who has had, say, 2 years of vSphere administration skills, who is VCP certified in data center and network virtualization. And then the document can be understood, and they might have a couple of questions. But if they've never touched vSphere before, then they need to do the ICM course, right? They need to do the NV courses. They need to maybe do a troubleshooting course before they can actually accept all those documents.
Yes. And so when I looked at the ICM courses, right, it's geared towards day one. So John and I and a couple of us looked at it and said, okay, so you know how to provision the VMs. You know how to create a clusters, right, because you've gone through these ICM courses, but you don't understand CPU scheduler. And you don't understand how ready relates to co-stop. And so we think that there is a need to have a day two So an architect can have a peace of mind. When I hand over to you, I do know that you have that basic level of operations.
Yeah, absolutely.
And you know how
one
performance.
Of the values. Sorry to interrupt there. I think this is one of the values of having an architect who actually can implement, because there's a lot of architects, and I'm not talking about enterprise architecture. That's a separate field, but there's a lot of people who are solution architects who actually have lost their hands-on skill. They either didn't have it in the first place or they've lost it over the years. And I think it's very important to maintain the hands-on skill to be a good architect. You don't necessarily have to be the best hands-on person in the world, and I'm certainly not, but you need to be very proficient. You certainly should maintain, say, a VCAP level of implementation skills. And otherwise, you're making decisions which are affecting, mission-critical environments in a lot of cases. And if you've never installed and configured those products, or you've never troubleshooted them, you can't be called in to help in the event of a problem. Yeah. And for me, anytime I design something, even if it was 10 years ago, if one of my old customers from 10 years ago called me and said, hey, we've got a critical situation, assuming they were still running something I designed 10 years ago, but in theory, right, I would get in there and I'd be able to help them, because I don't design things that I don't have hands-on experience with. If there is a part in my skill set which is missing, I'll make sure I get an SME to come in and lead that piece, because I'm just not willing to make assumptions and guess with architecture.
Yeah, agree on that. Agree. Yeah. As I said, it's the hands on the keyboard. That's your real architect.
Yeah, and look, when something does go wrong, you need someone who understands how it was designed and implemented and understands day two operations, and then they can give good guidance in, a moment's notice. You don't want someone who has to go away and do 4 days of research before they can give you advice, because you'll be offline for 4 days.
Yes. This reminds me of troubleshooting in KL in Malaysia. I was doing a workshop, and around 2 o'clock, it was interrupted. So we got about like 15 people in the room, and we got interrupted because SAP, which is that was their mission critical application, SAP was slow. Right? SAP was slow, so workshop is over. And so I said, if you guys are willing, since the data is in VROps anyway, I'm going to troubleshoot it if you are willing. So and they're willing to do it. So we turned it into a troubleshooting session, right? And when we looked at the pattern of the metrics, I said, guys, I'm seeing the VMs that are affected. I'm seeing the network packets coming out in a high ratio compared to coming in, and this is coming from the guest OS. And I said, this looks like a pattern of a backup, of an agent-based backup, guys. So why don't you take a look at talk to the backup guy, and see whether that was the problem. And so so when we did that, the backup guy checked and says, no, we don't do backup. There is no backup. So we did another round of check, because they have 6 vCenters. So I checked different data centers, right? And there's a VMAX also. And the VMAX guy was the DMC VMAX said that, all my LANs are busy. Anyway, all the LANs are mounted by ESXi, so you guys are the one causing it, not me. Right? So now the platform guy was in between SAP and storage guy, right? So since the backup guy says no, so we did one more round of check. I came back, guys, it's still the backup, because that is the pattern of, I plot the VMs. I said, I'm pretty sure it's the backup. Why don't you check it one more time? And then they come back to the backup team. By then it's already like 5 o'clock. Then the backup team says, oh yeah, SAP has a different backup schedule. We didn't know that. So that was the backup, And it's been going on for basically 6 months, except that was the time the user complained.
And importantly, you had the data and the knowledge to be able to highlight what that traffic pattern was, that it is unusual. And the only other example I can think of off the top of my head is a data exfiltration in a ransomware scenario where everything's getting pulled out. That's another pattern where it's all out and nothing in. So either way, those are bad situations. So I've seen agent-based backups cause all sorts of problems in my career as well. And the fun one, of course, is it saturates the storage, but it also causes a lot of CPU contention. Back to our original point, is the contention is caused because all the VMs are trying to do everything all at once, which is not how overcommitment works. So,
correct.
In the old days, it was staggering your backup windows across VMs and things like that, which helped mitigate those risks.
Yeah, we've seen that in VDI in VMware. So in VMware, VMware IT was telling me, Iwan, the users in Europe were complaining. And since they were served out of India, right? So we looked at, it's true, man. Your ESXIs spike up at a time. It took us a while to get it, but apparently it's not an agent, but it was from the network. It remote login. So there was a manager that is sending instruction, logging to all this desktop and run something at the same time. So that was the one causing it.
Yeah, I've seen those as well. Certainly, contention with VDI. It's one of those things where VDI can potentially overcommit a lot. But when operationally, actually, if we talk day two, if you perform things in a virtualized environment in the same way you did in a physical environment, you can potentially cause a lot of contention. So very important to understand the underlying infrastructure before making day two decisions on how we're going to do things.
Yes. This is why that knowledge again of the design knowledge, right? You have to know design, you have to know architecture, you have to be hands-on. Then the troubleshooting will make sense. Then the metrics will make sense to you.
Absolutely. So maybe we should cover off some networking metrics quickly, because you touched on, whether it's ingress or egress traffic. Obviously, if there's a lot of egress traffic, it is potentially a backup, an agent-based backup causing that issue.
Yes. So network, right? You can see the screen. Okay, maybe what I'll do, I'll stop sharing this thing and I share back window metric here. Okay, network is interesting. So one reason why I document in the order of CPU, memory, storage, and then network. I do network last. And Bruce Davey. I'm sure everybody knows Bruce Davey.
Yeah, absolutely.
Right. So I was like asking Bruce, how this network? I'm not a network guy, and I found that network has a unique characteristic that makes it. And I listed all these unique characteristics that I feel make it difficult to monitor and troubleshoot the nature of network as an interconnect. While the nature of storage and compute, they are nodes. They're just nodes, while network is distinct. I can see this ESXi, I can see this cluster, I can see this storage array. But network, they're just cables, basically, so to speak, with switches, right? And they don't hold data permanently. It's just in and out, basically, right? While compute is your VM is running there could be running there for days, right? And Bruce was telling me that it is there isn't much in a sense documentation on enterprise network. How do I quantify a network? Basically, if you have what is health? Okay, what is health? First thing, is it up? Because if it is down, there's no need to talk about performance. It's dead, right? And you are secured. Nobody can attack you because it is dead. Right. So first thing is availability. Okay. So just because something is up doesn't mean it's fast. Just because something is fast doesn't mean it's secure. So to me, this is health, and because this is right now. Now, of course, just because something is fine today doesn't mean it's fine tomorrow. But that is capacity. Yeah. So in these three parts, if let's say you have NSX, you have hundreds of edges. You have your DLR, right? You have your distributed firewall, etc. You have your NSX managers, and then you have your top-of-rack switches, right? You have your gateway, etc. And multiple data centers. And I want to ask you, okay, say I'm a CIO, right? Josh, okay, can you give me one chart? Can you give me a dashboard? I want to see the health of our network. It's very difficult. To quantify, to roll up something at the CIO level, right? Because you don't want to show the technical details, right? It's irrelevant, right? And he just want to see, is it up? Is it fast? Is it secure? Just give me three numbers. My entire network. Okay, and I'm not asking the architecture. I'm asking the state of it. Then give me a trend chart so I can see. And I expect they all just 100, 100, 100. That's it. Just grin. That's all
Just
I
give
need
him
to
a
know. I don't
screenshot.
need to
That's all
know.
he needs.
So this network, it's something that I'm trying to model. So in the book, a lot of them are about modeling. I'm trying to model the health, the performance of a VM, the availability of an ESXi, because ESXi has many components. You got VPXA, you got host D, you got the various daemons, you got NIC card, there's a lot of things in ESXi. It's not black and white. It's not just up and down, right? So how do you model all these things, right? And to some extent, we model a cluster performance, we model a VM performance, right? And network is hard. I've been asking a lot of the network guys. It's like, can you give me a number, 0 to 100, okay, of the availability of your network? I do not care how many top of rack switch, how many end of row, physical, virtual. Just give me a number 0 to 100, because if it is not 100, I'm going to call you. Because I'm not the network guy. I'm a consumer of your network, right? My ESXi are connected to your top of rack switch. From there, whether you go Bluetooth or wireless, is up to you already. I only care that it is up, fast, secure. Give me 3 numbers. It is hard. I think this is something that we can, my take on it is eventually we can crack it. It's not going to give a good, perfect answer. Just like you don't have a perfect answer for the economy performance, but you have stock market. It's a rough guide. The stock market goes down, that's not a good news. Generally speaking, your inflation rate. Okay, I know inflation rate varies. Your inflation rate may not be the same with Mike Sumner inflation rate because he has a different basket, basket of goods. But in general, in Australia, you guys agree on a number. Right? So that you don't debate it basically, right? You move on with life, right? And so the same thing, I think, with some of these metrics, we move on with life, we accept it, we know it is not perfect, okay? But we say it's good enough, guys. What we care is it doesn't go down. That it stays at a number, that it doesn't go down. That's what we care. Right?
And that's your minimally viable solution as well. So as an architect, I would define that as what's our minimal product, or if you're designing a product, it's minimally viable product. What's that minimum standard, that SLA that we need to adhere to? And are we meeting it? Yes or no? As a CIO, that's it. It's a very binary answer.
Yes, correct.
And if we didn't meet it, why not? And what can we do to make sure we are meeting it?
Correct. I think you brought up a good point. I want to share that basically there is a service level which is not technical, because whether I'm using, in a sense, Intel or AMD, it's kind of irrelevant, right? And it's a CPU as a service. And what you care is at the moment you are asking the CPU, is it available or not? Right? So we can agree on a set of counters for that. Now, once we agree on a set of counters, it's a function and a threshold. It's a function. Do I meet it or not? Yes or no? It's a yes or no numbers. And I promise you, within 1 month, for example, let's say 99.99 times, that I will deliver that number. I'm not going to promise you 100% because that is a bit risky, and then I don't have a room
burst or something like that, which can impact that number. So,
right. So that is a service level. Now, on the other hand, there is, like what you said just now, if it doesn't meet it, I want to know it. I want to know it before you know it. Because if you as a customer know it first, it's too late for me already. I'm reactive already. I want to know it proactively. So I came up with a concept called KPI. So there is a KPI and there is an SLA. Where is it? So this is SLA. And
here's the 3 points you mentioned. Is it up? Is it secure? Is it fast?
That is correct. Yes. And then the KPI is a technical, this is KPI. This is KPI. So KPI and SLA, right? So I just easy like this. Now, So when you have your VM in my environment, in my IaaS, right? You care about certain metrics. I give it to you. Now, the KPI is a much broader set of metrics that is supposed to, that should are leading indicators so that I avoid from breaching the SLA to begin with. An example, vMotion stun time. vMotion or ESXi's kernel queue. My ESXi kernel queue is not part of an SLA because you're just a VM. Why should you care about my kernel queue, right? And vMotion stun time. Well, it is true. It is about your VM, but I'm not sure whether I'm comfortable putting it as an SLA because that is a pretty low-level stuff that is hard to control, right? And so this KPI, I track it, and I make it serve as a buffer for me, right? And the KPI, there are KPI on each of these things. So there are metrics on each of these things. There's a VM KPI, there's a Kubernetes pod KPI, there's a cluster KPI, vSAN KPI. Back to your network, there's a network KPI, physical network KPI. But SLA is always in between two parties. Yeah. So I think if we can go towards this, it makes us less relying on complaint and debate. It's all based on raw data.
Absolutely. And I think your point about monitoring something so that you're aware an SLA breach may occur if that is not remediated is a really good point, that there's a trigger where we need to start really looking at something. Oh, this is getting to a threshold where an impact might occur. Let's start troubleshooting this now as opposed to when the SLA is already breached. Like you obviously want to prevent that scenario. So I think, like you say, that there's different metrics that we want to look at, and the KPI of the vSphere cluster in your diagram is a perfect example that all of those lead to the SLA that the CIO cares about. And ultimately, those are the people I talk to the most, is CIOs and architects. So, the CIOs want a business outcome, and they know they want a couple of metrics which they can measure it on. So I need to map the physical, technical layer to the CIO's business layer and give him something that he or she can understand.
Yes. So it's how do you translate that magically, right? And the other thing is, you talk about there's now the SLA, right? So there's insight and alert. So alert is like you fall sick, you really got to go to the hospital. You're not feeling well. You know it's not good. I got to go. So you're being alerted. Okay, something is bad happened. Okay, a symptom is you got a bit of headache. You may think, man, I'll just go and sleep and see how it goes. So a symptom, you may notice certain things. You notice that the disk latency went up, but it is not yet bad. And you notice that the vMotion took a little longer than usual. It's not 200 milliseconds, it is 300, but it's okay. Your threshold is 1000 anyway, so you feel okay. So that's a symptom. You're watching it. You're watching it. An insight, it's something that you do to prevent the symptom from happening. This is going back to the check. What do you check daily? Examples. You just upgraded your storage. So the vendor, according to the spec, you replace magnetic with SSD. According to the spec, it's going to be a slam dunk. It's going to be a 5 times faster. So that got you confident to tell the CIO, no problem, load, we can bring on all those VMs, no problems, because I just bought something that is 5 times faster. Okay, so then you do an upgrade. You migrated the VMs. Okay, so 1,000 VMs migrated. Okay, and your plan is 2,000. Then you saw that the improvement isn't 5 times. You haven't added the workload yet. It's an existing workload. You haven't added the new one, but it's not 5 times. It's only 2 times better. It is better. It is better, but it's only 2 times. So now you're shaken because the plan is 5 times, guys. This is insight. There is no symptom. It's good. This is what I meant by proactiveness, that the proactiveness cannot be done by a help desk guy who just mechanically does things. This proactiveness is done by somebody who understands the big pictures, that knows context of operation. We just did a major upgrade. Knowing the business context, operation context, and say, guys, the numbers don't support the idea.
And I'll give you a really good example, or I'll give the listeners a really good example of this. So in your example, you mentioned a customer's going from magnetic to SSD. And of course, SSD is far superior to old spinning rust. So what happens typically that I see is people go, oh, we're going to performance will be 5 times better or 10 times, whatever the number is, they think it'll be better. But storage, if it's not a constraint, it won't improve performance at all. So when you remove a constraint, that's when performance changes.
That's right.
So that's one thing I find. The other thing that I find very interesting, because I see it a lot, and I've seen it recently. A customer installed a new pure storage array, and they were complaining. They were like, oh, what's going on here? Our CPU utilization is way higher after they installed pure storage. And they were complaining, oh, this pure storage is terrible. No, pure storage isn't terrible. You got a great result. Your CPU was sitting there idle because the storage was the bottleneck.
Yes.
So when they put pure storage in, the storage performance was so much better that the CPU all got utilized. So I was telling them, this is a fantastic outcome. This is exactly what you wanted. You got a great outcome. We worked out what the contention was. It was storage. You put in pure storage, and now you've got higher CPU usage. Fantastic. You should be very, very happy. This is not a bad thing. So understanding the metric was key for that customer to realize pure wasn't actually a problem. Pure was the solution to their problem.
Yes. Yeah. It's true. This is what that's why I wrote it down here, right? And when a batch job that takes 8 hours now takes 2 hours, well, you still process the same number of transactions. So what do you expect? The CPU is going to go up by 4 times.
Yeah.
So a VM that was undersized now it become there was oversized, now it become undersized.
Yeah. And actually, the other thing that I see less often, but I see this still quite often, is you get better storage, and then your CPU ready actually goes down because you're processing faster, which means that the storage was the bottleneck. The CPUs were always busy waiting in that wait state.
Yes.
And then that caused contention. So when you upgrade the storage, your CPU ready actually goes away, and your CPU utilization goes up even more because you've relieved the constraint of CPU ready, and you've relieved the constraint of CPU wait on the storage side.
Yeah.
So a lot of the time, CPU utilization going up is in fact, most cases, it's a good thing. Something good is happening because it's actually using the resources assigned to it.
Yes. So it's doing work. It's doing work. Right. That is why one of the things that I saw the customers started doing, that's why I wrote it down here, is there is what we call it the baseline profiling. That you want to, if you got 10,000 VM, you want to profile 10,000 VMs. And you wanna arrive at a KPI so that you know your baseline performance, so that when you make a change in the environment, be it a tech refresh or etc., you can see the baseline change. And only when you have a baseline, then you got comfortable developing an SLA. And this baseline, it takes some time to execute. Because if you got like 10,000 VMs, you got a baseline 10,000 VMs. Especially if they share the same environment, right? Production and non-prod share the same array, etc. You baseline it. And so I had some methodology here, right? And certainly happy to have a discussion on that. And then I had a set of dashboard that I document, what metrics I use, what metrics I do not use, right? And then how do I baseline it? And an example is like this, right? So this thing is based on 20-second peak vCPU. So if a VM has 8 CPU, I'm taking the highest among the 8, and I'm taking 20 seconds, not 5 minutes, right? And I profile it over, let's say, 3 months. And so when I profile over 3 months, then I plot it over time. This thing is perfect. It's over here. All right. And as opposed to something like this. Right. So at least I have a baseline. So I do know what to expect when we make a change to the environment or when I want to establish an SLA.
And this graph
so you
here
do
you've
the
got is a
CPU.
perfect example where, had we had a storage constraint that I just mentioned earlier, the second chart you showed where the CPU ready was, all over the place, it would turn into the one above it where there was almost no contention. So that baseline is so important to validate that the assumption made that the storage was the constraint or the host the constraints or whatever has been alleviated. So absolutely, those metrics are critical.
Yeah, I hope that more and more customers can move towards a data driven. So that before, because when you make a changes, migration, upgrade, etc., have a before and after. So you feel confident. You're not waiting for something bad to happen, then you react.
Absolutely. And I think CPU ready, like this is a great example on screen right now that if you are changing your hosts or if you are changing your storage or you're doing anything in your infrastructure, this is one I think you should monitor, because if your CPU ready is increasing, you need to back out of whatever change you've done, because this is going to definitely cause you issues. And unless the change goes from like 0 to 1% to some of them in 1 to 2%, which might not matter. But if it went from the top graph to the bottom graph after a change, you should declare that change failed and you should revert immediately, because you will have very significant ongoing challenges if your CPU ready is like that bottom chart. Even VMs in the, let's say, 2, 4, 2, 3, and 6 category, so the yellow, the orange, and the pink, those VMs are suffering significant contention at this point. And if they were business critical apps, they're probably having serious issues. And the one thing I've seen as well, I've actually labbed this as well, just out of interest to see how extreme this gets. If you have a web app and a database server, and then one of them is in a ready state, but the other two depend on that one VM, the whole lot slow down because they're dependent on each other. So if you have a situation where there's contention at any layer on any one of those three apps and they are dependent on each other, it exponentially gets worse. And that's a very simple thing for anyone. Jump in a lab, run up CPU busy, and try and run an application when all the cores are saturated and you can't schedule. You'll just get no performance. So that graph at the bottom there is a great example of what you have to avoid. And that's probably, I would say, the most important tip in virtualization is understand CPU ready and how to minimize it and how to identify it and remediate those situations.
Yeah, this is I want to share with you what customers. One of the things that I like doing is I like just doing dashboarding with customers, and I'm going to share with you what a customer in Malaysia. Where is it? This is talk about the business application, right? And this is strange. Okay, maybe I'll change to PowerPoint then. Essentially, right, he told me he got tired of being called into a room and explain that it is not because of his infrastructure. This is a bank. Right?
Every admin ever has said that.
Right. So I can share this thing and this guy. Okay. So then he said he scribbled on the board, Iwan, I have only 11 the number one application. So give me one box per application. Right? Like one of them is internet banking, for example, right? And number two is something whatever. And I want it to be color coded. And I want to be able to drill down from the business application into a tier, web tier, like you talk about DB tier, into a component of the tier, right? And then from there down into Windows and into the process. So we developed this dashboard, and then we developed the model And we developed the formula for it. Like what you say, right? The business application is the worst of the tier. Because if one tier is affected, everything else is affected. But within the tier, it's an average because it is scale out, right? So, and then within the VM, they develop a set of numbers, a set of KPI, right? And then based on that, and then develop a dashboard. The dashboard looks something like this. So each of these things is a business application, color coded, right? And so this could be internet banking. And then when you click on one, it gets into the tier of the business application. And then when you click on one of the tier, it gets into the VMs in the tier. When you click into the VM, it gets into the services inside Windows or Linux, right? And then I didn't put it here, but from here, you can jump into Windows or Linux dashboard. And then on top of that, he added the average of all this guy. And so now he has a stock market index for his company from an infrastructure standpoint. He says that, look, this is the average of all of you. You are the top, whatever, 20 most critical business application. Just look at this number. If this number drops significantly, that is not good because it takes a while. It takes a lot. And one of these apps, for example, can contain hundreds of VMs, right? And so this is a dashboard that was developed, and then from there you can drill down into. This is a single VM, right? You can drill down all the counters one by one, right? And so he has it basically being able from the top going down. And I said, now you guys self-service. You can see your one another application. Everything is transparent, guys. I do not favor one over the other, guys. Look at it. It's the same formula being applied to all because you are all mission critical. You're in the same class of service, right? And we agree on this is we agree on a set of threshold. Okay, and I'm gonna apply this threshold.
Yeah, and then we get a baseline. Then when we look at this dashboard, we can say, okay, it's mostly green, it's a little bit orange, maybe a little bit red. And then we as architects can look at it and go, okay, what's causing this red piece, right? Or that orange piece? And we can actually design solutions to address it. We can then implement those changes and then measure against those changes and then see the actual outcome versus what we assumed would happen. And then obviously make sure that the customer gets the outcome they need. So this is a great example of defining something measurable that you can create an artifact and then give to the customer and say we were successful. So it's not just Josh coming in and saying, hey, we've made things run 5 times better. And the CIO goes, but how do I know? Oh, you just have to trust me, Mr. Customer. Like, I'm a nice guy, right? And I'm telling you everything's great. No, that's not good enough. We need to provide artifacts so that it's measurable. And it's not just measurable when I hand it over. It's measurable for the life of the solution.
Yes. Absolutely.
Yeah, so this is a great example of something I think a lot of great architects do, is create things like this. And what's on the screen here is a great example. You know, you've got contention utilization at both the guest level and the VM level. And you've got IaaS written at the bottom as well. So, yeah, this is a really good example.
Yeah. And what I find useful is I tell customers, sometimes the messenger matters. If you are the one telling your counterpart in an application team that the CPU ready should be 2%, they may not believe you. But you get somebody else that is neutral to say it. It makes a difference.
Yeah, look, it does. And certainly throughout my career, I've noticed that, you know, I've been asked to come into, whether it be a customer call or fly into a customer, and the account team or the other architect or a colleague, whoever, has said, oh, Josh, this is what we've recommended. What do you think? And I'm like, yeah, that sounds correct to me. Like, let's look into it a bit more. You do your analysis and your due diligence. And then I look and I go, yeah, I would recommend exactly the same thing. But it just takes me coming in to back them up to get that message across. And I think that's the value of having external consultants as well, especially from independent partners. That can come in and validate what a vendor says or what an internal, operations team member says. And that's the value of that consultant, is that they can do that.
Yeah. Because the application team will say that you're the infra guy, you have an agenda. Okay, this number, you said it, so it's good. So let's get somebody else.
Yeah, and I think the other thing is, as an independent person, certainly myself and my team now, we can just come in, we just give our opinion. It's not tied to a vendor. It's not, no one owns our opinion. So we just come in and we say what we believe is true, and we back it up with data. So, I think in those situations, excuse me, where you have that conflict inside an organization, we can come in and we can say, we want to make the app run fantastic. We want the infrastructure to run fantastic. We want the CIO to be happy. Our goal is everyone to be happy. It's not just to make an infrastructure person or a storage guy or whoever happy. It's the whole customer has to be happy. And
that's right.
The bigger the company and the bigger the organization, the more of a challenge that can be. But I always find that sitting down with each of those stakeholders, understanding what they're trying to achieve, and then what I present back to them or the advice I give them will vary, obviously based on the audience and their technical capabilities and things like that as well. But, I will always make recommendations to improve, every layer of an environment. Resiliency doesn't just happen at the storage, right? There's resiliency, at the application layer that needs to be considered. So I will always highlight what I think the issues are, and also what else should be done in addition to that to improve the situation and be proactive, not just reactive to issues.
Yeah, you mentioned earlier that you make everybody's happy, right? One of the things I observe, that's why I have it here, that when you have an architecture such as IaaS, right? As an architect, you convert an SDDC into an IaaS. So what you bought is an SDDC, but what you sell is an IaaS. It has to be consumer-oriented in a sense, meaning that when I look at vCenter, for example, right, I like to see the business reflected in the environment, like the folder structure. If it has to be business units driven as opposed to an infrastructure driven, right? And so that the operation team is always, in a sense, application centric or business centric, as opposed to it's just a bunch of VMs, and we don't know. We just deal with VMs. No, you need to understand the business and the applications, and that is why it has to be reflected. Same thing in the naming convention. Same thing in the tagging, right? And this is, to me, is a mindset that they need to do. Sometimes customers tell me, hey, when I come on site and I do a review and say, Iwan, you give us a lot of homework. And because I ask them, okay, so what are your top 10 business applications? We know their names. Okay, so where's the VM? We do not know where the VMs. They're everywhere. Don't have a naming convention. I have a customer that has, I believe it was about 64 clusters and a couple of hundred data stores, right? And he wants to have a 3-tier: gold, silver, bronze. And I said, okay, I can build a dashboard for gold, silver, bronze. Okay, tell me, now how do I know which one is the gold clusters? We don't have a naming conventions for that. The HP one is gold. And I said, you have two choices. Choice number one, I'm just going to hard code all this thing in my dashboard. Choice number two, rename your clusters, rename your data store. Two choices. So since he did not want the hard code stuff and he want to make it future proof, rename everything. Right? Or like the VMs, right? We have mission critical VM, but they are everywhere. They are in this cluster, that cluster, this data store, that data store. We don't know where they are. And if I'm going to make a dashboard for you, well, either I will hard code the VM one by one, or you either put them in one place where they can be monitored easily, or you have a naming convention that we know what the class of this VM.
I mean, I've seen the problem many times where people don't know anything about their environment. They know they've got 10,000 VMs. They know they've got 500 hosts or whatever, but they just don't know what all their apps are and what the VMs do. And I'm literally working with a customer right now who, they're like, oh, we think we can probably get rid of about 30% of our VMs before we migrate up to Azure VMware solution. I'm like, okay, cool. That's a nice assumption, but we need to make sure that's correct. Otherwise, our sizing in AVS won't be correct, and it'll cost more and this sort of stuff. So a naming convention's a great idea. But also, if you don't know what your dependencies are, then when you have contention, we can't resolve it for an app. We have to just resolve it for everything. Like if you have a critical situation and an application, just one, is running poorly, and we know what all those VMs are, then we can just move those off. We can just shift them manually. We can turn DRS off. We can throw them on a host with no contention, and we can kind of resolve that in the short term and then work out something, in the medium term. But if we don't know which VMs they are, we have to solve the whole environment's problem, which is obviously not usually very quick and easy to do. So simply focusing on understanding what's in our environment so that when we have to address issues, we can address it for the most important VMs first, and then obviously do it for the rest. And this is a great example of where people get Site Recovery Manager wrong. They try and fail over everything, whereas when you're failing over in DR, you really need to classify your workloads so that you're only failing over the stuff you need, so you can get your recovery point and your recovery time objectives as aggressive as possible. Because the more you fail over, the longer it's going to take. So there's so many reasons why people should be doing what you're suggesting here. And naming conventions is something that I think 90% of the designs I've reviewed in my life do not have. And I think it's a big mistake. And I've certainly made that mistake in the past as well, so I'm not perfect, but I certainly try to do that these days. And it's just so important for so many reasons.
Yeah. Agree.
So I think that's a big tip. We've got to, I'll make a clip out of this one, that everyone needs to focus on their naming conventions, not just for performance, but for business continuity and disaster recovery, things like that.
Yeah. So you don't work on the wrong VM.
Yeah, absolutely. You don't turn the wrong thing off. You don't delete the wrong thing. Like you don't, you don't back up the wrong thing or not back up something that you really should be. So yeah, very important. So I know I didn't want us to miss the storage metrics as well, because storage is obviously a key topic, and I think we've skipped over that a little bit. So maybe let's focus on some storage metrics, and we can finish off on this point, I think.
Yeah.
I'm certainly going to invite you back on the podcast, because I think we can certainly deep dive more into some of these in the future, because this has, I think, been great. But let's focus on storage.
Happy to do that. Yeah. I think in storage, my 2 cents is we look at the storage architecture. So okay, maybe if I do it like this, in a sense, like this, right? So when a VMware admin go to vCenter and says data store this, virtual this, and they may not know how are they related. What should I expect on these things? And the reason for that is because I would say we could present the storage layers better in the way so that people could understand how these numbers are meant to relate. And so that's one part. The second part is and I haven't documented yet, as you could see, I haven't documented a HCI like a vSAN. How does vSAN impact this thing? How do you do that? Right. So that is at the VM level and a vSAN. The second part is I think when customers looked at the ESXi. By the way, the screen hasn't changed for so many years. How does the path, the adapters, the device, right? How are these? Hang on, this is CPU, memory, storage here, right? So when you look at it, this is ESXi, and then okay, so we got a data store, we got this, we got adapter, we got path. So which one is which, right? And what do they mean? How do I interpret that? I think I find that it's useful to understand this part, that having this understanding of the architecture and knowing how it works, then the numbers, then you know what to look for in the metrics. So that's one part. And storage feasibility, as you get down from from consumer to providers, and there are, as you get down from partition, this is only knowing partition. When you go partition, C drive, D drive, etc., and then you go to virtual disk, you go RDM, and then you got LAN here, the feasibility and the mapping is lost. So this makes it hard to troubleshoot. And that's why I prefer, when it comes to storage, keep the relationships simple, like one partition, one virtual disk, and then you don't one data store, one LAN, one VM, one data store, because you lost the observability, you lost the relationship when you go down. At the ESXi level, all those I/O, you do not know which VM it is for. You lost that thing. So that is my take on storage. I don't know whether that answers your questions.
No, certainly. I think it's important to understand there's different metrics as well, depending on the type of storage you use. So I mean, in this diagram, you got a great example. You've got an NFS data store, which is obviously file-based storage. We've got a shared data store. We've got raw device mappings. We've got a vSAN data store. So these handle I/O, and the I/O path is very different for each of them. There's different layers of potential contention. With NFS, there's a single TCP session, for example, which can be a constraint for NFS performance. And then it can be the number of paths for fiber channel. And it can be ultimately the CPU, obviously, in something like vSAN, can be a constraint as well. So there's lots of different areas where we can get constraints at the storage layer. We need to, as you rightly mentioned, make this as simple as possible. And we don't want to be measuring 50 different things, and we don't want to have, different data stores on the same physical LAN, because again, that makes us, we have to monitor two data stores for one LAN, and that just makes it exponentially more difficult. So keeping our storage design simple and having a scalable and repeatable model is very important for troubleshooting, and also for upgrades and things like that down the track. Like if you're going to, upgrade your VMFS, for example, you want to know everything about your environment before you do that. You don't want to be upgrading a data store when all the hosts aren't at the correct version, for example. So there's lots of things to consider.
Yeah, and storage, unlike in a sense CPU and memory, storage there are two sides of it. There is a space and there's a speed. The space is in gigabyte. The speed is in IOPS, millisecond latency, gigabit per second, right? And the space itself is quite complex. And certainly having the knowledge of how all these files in a VM, right, of virtual disk, snapshot file, other file, uncommitted, unmapped, knowing how this thing works, and then you'll be able to manage your capacities better. You will not be having, I would say, maybe too much buffer as a result, because you are concerned.
Yeah, absolutely.
And
I think
there
again,
are,
the
in a sense,
is critical here. So as we talked about CPU, the context is important for CPU utilization. The context for storage is important as well, because high latency and high throughput might be perfectly normal and fine, whereas high latency and low throughput would be very bad. So that would be a different block sizes and things like that. So context is important for these metrics. So there's not always a right or wrong. Latency may go higher for certain workloads, and that may be very acceptable, but it may be completely unacceptable for other workloads.
And then the other thing, when it comes to storage, knowing the virtualizations where storage is implemented. So in the case of vSAN, because it is a virtual storage, your actual VMDK gets enlarged. And so you can't tell it. And there's only one file. In that one file, there are three components. There is a use portion that is used by, contain useful data. There's an unmapped portion. And then this entire thing get FTP protection by vSAN. So there are three parts inside a single file, and you do not know which one is which. It's a little tricky. You got to if you do your partition to VMDK mapping 1-to-1, yes, we can potentially do a sum of all your guest OS, right? You do a delta basically. You compare your delta versus your use, right? And then you take out the vSAN FTT. Then you can check if it is not 0, then you got an unmapped file, unmapped block.
Yeah, absolutely. So, I mean, that's a great example of, a HCI or a vSAN scenario versus, an NFS, 3-tier type solution.
Yes.
Very important to understand the metrics, how it's implemented. And also, one thing we didn't talk about in the CPU section earlier was if we are correctly configuring our virtual machine, such as putting paravirtual SCSI adapters in, this can lower CPU utilization because there's lower overhead than an LSI logic, for example. And this, again, can drive better storage performance, which could increase CPU utilization. So if we were to convert, a legacy virtual machine from an LSI controller onto paravirtual or multiple paravirtual, ideally, if it's a high-performance machine, then you might actually see the CPU utilization increase significantly as a result of removing the storage bottleneck. So the success criteria we need to define needs to be well understood. So in that scenario, higher CPU utilization is a desired outcome. If we can achieve higher CPU utilization, we are very happy. If CPU utilization went down, it's more than likely not a good thing. There's probably a scenario where that would be fine. But in general, if you're putting paravirtual adapters in, you're trying to relieve a bottleneck, which should lead to more utilization, not less. So again, context is critical.
Yeah, more work being done.
Yeah, absolutely. Yeah. So I think we've covered off a lot here. We've been going for almost 2 hours. It's fantastic, Iwan. So I think we'll wrap it up for part 1 of this, and certainly looking forward to having you back on, and we can dive into some more specific scenarios. So a huge thank you to you, and I'm sure everyone's enjoyed the episode. I've certainly enjoyed it.